Hello everyone, my name is Lauren Frisky and I'm a team member of Team 13, aka Circuit City. Our robots altogether are called the Reforestation Bots.
Hello, my name is Sophia Smith and I will be presenting the sampler bot.
Hi, my name is Jessica Piper and I will be presenting the Digger bot.
Hi, I am Eve Benjamin, and I'll be giving a quick rundown on the planter bot.
I will be presenting to you all my robot, Waterbot. Every year, 2 million hectares of trees are lost to agriculture and logging. Our team proposed to develop a group of autonomous operated robots. Its mission is to reverse deforestation. In furthering reforestation efforts, our mission is to continue to reforest areas negatively impacted by deforestation. Robots in the past have helped humanity and the world in many ways, and now we're hoping to utilize them in combating climate change in relationship to deforestation. Reforestation can even have a positive impact on local communities by increasing water retention, carbon sequestration, and increasing food security.
For our proposed robots, we have the sampler bot, which will take a sample of soil and bring it to a testing station to determine the water levels in the soil. Next, we have the digger bot, which will make holes in the soil for the saplings to be planted in. We have the planter bot, which will plant the saplings in the holes that were made by the digger bot. And finally, we have the water bot, which is a drone that will water the saplings that were planted by the planter bot.
This is the sampler bot. It has two sensors and two actuators. The first sensor is an ultrasonic distance sensor. This will help it from getting damaged by any objects. The second is a soil moisture sensor. This will test the water levels and send it to the water bot. The first actuator is a DC motor that will propel the robot forward and backwards, and the second is a servo motor that will open and close the scoop.
The robot I've created is called the Digger Bot. It is powered by a DC motor which is connected to an HC-SR04 distance sensor, which will allow the robot to stop every 10 feet to make a hole in the soil. The drill is powered by a gear motor which is connected to a ping distance sensor, which will allow the drill to stop once the hole is a half-inch deep.
So the job of the planter bot is to drop the sapling into a hole and then cover the hole with dirt. So it has a sensor to tell when the trapdoor is over a hole, and has a sensor to tell when the hole is covered with dirt. And then it has an actuator to open and close the trapdoor, and an actuator to control the shovel.
So here's Waterbot. Off to the left, you can see a 3D model of it, and to the right of the slide, its circuit, and underneath it, a flowchart showing that circuit's algorithm. There is manual input involved, and it will be receiving manual input from the operator telling it where to basically fly at to water the saplings. What is automatic though about it is it will stop watering the plant once it senses the water levels in the tank are below 5 inches.
Here we have a 3D CAD model of our reforestation job site. To begin with, the sampler bot will get coordinates inputted to it by the operator. It'll go to these coordinates, pick up soil, bring them back, test them for water levels, send this information to the water bot, and the operator will test for the rest. Once the soil has been determined it's good enough, the digger bot will go and dig holes X depth and X distance based on the given trees being planted. Once completed, it will tell the planter bot that it can go plant those trees in each hole. The digger bot will go hole by hole, planting the trees and covering them with soil after it's completed. Once completed, the water bot will water the entire job site. It'll water based off of how much information was given to it by the sampler bot. Once the water bot has finished watering, the reforestation robot system is complete.
Okay, so now let's talk about the value added, right? So why use the reforestation bots over the current solution? Well, currently, reforestation is done through manpower, right? And it requires hard travel conditions and long hours. You see the picture, bunch of people gathered in the back by truck, where they're going who knows how far, and they'll be planting trees for who knows how long. And another issue is people will make mistakes, right? They might make the holes a little too shallow, a little too deep. The tree might be a little too close together, which will, ultimately cause the trees to die. So this is where the robots come in and make it much better, right? Robots can handle long distances and long hours a lot better than people can, as well as they're precise in their measurements, right? So all the holes will be exactly the same depth, they'll be the exact same distance apart, which will be optimal for the tree's survival.
Reforestation is a physically challenging and time-consuming process, but with the use of our robots, this process can be simplified and won't rely on human labor to restore forests around the world. Thank you for listening to our presentation.